Midpoint Theorem, Grade 11, Part 1. This is a triangle, ABC. Triangle has three sides, AB, AC and BC. Let's find midpoints of these sides. We'll bring A to B. Here is the midpoint of AB, named as X. Similarly, we can find midpoint of AC and BC also. We'll name those two are as Y and Z respectively. Then we got three midpoints. Any of these two midpoints we can join like this. That is XY. XY is the line joining midpoints of two sides of this triangle. That is known as mid-segment. And also we can find there's any relationship between this line segment and BC. That means BC is third side of this triangle. We'll see by folding here. These two are getting equal. XY and BZ are equal. If XY equals simple A, BZ also simple A. These two also getting equal. BZ is simple A, then we can say ZC also simple A. BC equal 2A. Can you see there's a relationship between these two lines? If XY equals simple A, BC is third side equal to 2A. Then look at this. Here can you see BC XY lines are parallel. And also here also right angle. Here also right angle. Then can you see here also should be right angle. Those two lines are parallel to each other. Then we can say another relationship between XY line segment, the line joining the midpoints of two sides of a triangle getting parallel to third side. That means here BC. Point theorem. The line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. Let's see ABC triangle. AY equal YC, that means Y is midpoint of AC. AX equal XB, that means X is midpoint of AB. So X and Y are midpoints of AC and AB. Then third side is BC. According to midpoint theorem, the line joining is this line XY. Then that is parallel and half of third side. First one, XYZ is an equilateral triangle. ABC are the midpoints of XY, XZ and YZ respectively. Prove that triangle ABC is an equilateral triangle. All sides are getting equal because this is an equilateral triangle. So A, B and C are midpoints now. So XB equal to BZ and YC equal to CZ and also XA equal to AY. All these lengths are equal when we divide it into two parts also, because this is an equilateral triangle. BC parallel to xy. BC means midpoints of two sides. Third side is xy. Then we can say BC is half of xy. Similarly, we will take AC. AC are midpoints of xy and yz. Now, third side is xz. Then AC is parallel to xz and AC is half of xz. Similarly, AB is another pair connecting these two midpoints, that is mid segment is parallel to yz and also AB is equal to half of yz. xy, xz, yz. xy, xz, yz are equal because this is an equilateral triangle. Therefore, AB, BC and AC are also getting equal half of that length. Therefore, ABC is an equilateral triangle. Second one, AB and C are midpoints of xy, xz and yz of a triangle xyz, in which xy equal xz. Prove that ABC is an isosceles triangle. Let's see the triangle. xy and xz are equal. So, we can consider AC's line segment, midpoints of two sides getting parallel to the third side, and also AC is half of xz. Similarly, BC will take midpoints connecting line is half of third side, that means xy. According to midpoint theorem, xy and xz equal because this is isosceles triangle. Therefore, we can say AC and BC also getting equal half of that length. Therefore, ABC is an isosceles triangle. Third sum, PQRS is a parallelogram. PR and QS meet at O. A and B are midpoints of PO and QO respectively. C and D are midpoints of SO and RO. Prove that AB parallel to CD and ABDC is a parallelogram. PQRS is a parallelogram. PR and QS intersected each other at O. A is midpoint of PO, B is midpoint of QO, C is midpoint of SO, D is midpoint of RO. We have to show AB and CD are parallel. AB we can say parallel and half of PQ. Why? These two are midpoints. This is the connecting line joining, that is known as mid segment, is equal to half of third side, that is PQ, and also parallel to PQ. CD parallel to SR. Why? When we consider about OSR triangle, these two sides and these are midpoints. So, midpoints connecting line parallel to third side and half of third side. Then PQ equal SR, we can write PQ equal SR. Why? Opposite sides of a parallelogram that you know. Therefore, ABDC is a parallelogram, this one. Why? A pair of opposite sides are equal and parallel. These two are equal and parallel. Fourth one, L and M are midpoints of XY and XZ of the triangle XYZ. P and Q are the midpoints of XL and XA. Prove that PQ, LM, YZ parallel to each other. Second one, PQ equal 1/4 of YZ. Look at this XYZ triangle. L and M are midpoints of XY and XZ respectively. So XL and LY are getting equal. We can give same signs. And also XM and MZ are equal because M is midpoint of XZ. We can give same signs to these two also. And also we can say LM parallel to LM is connecting line of two midpoints, and that is parallel to YZ, that means third side, and half of LM is half of YZ, that means third side. And we can write PQ. We can consider here now small triangle. PQ parallel to third side, that means LM, and also half of LM. We can write PQ, LM and YZ are parallel. Then we can write PQ equal half of LM. PQ equal half of LM. And also you know LM equal half of YZ. Therefore PQ equal 1/4 of YZ. We will see you on next video. Thank you.